Good day, everyone. Today we're going to tackle about Introduction to Linear Regression, exploring linear regressions. So for our lesson outline, we're going to have an introduction to linear regression with 2 examples and regression analysis with 3 examples and solutions, all in all 5 examples. So moving on, what is linear regression? Linear regression is a data analysis technique that predicts the value of a known data by using another related and known data value. It mathematically models our unknown or dependent variable and known or independent variable as a linear equation. The question is, why is linear regression important? Linear regression are relatively simple and provides an easy to interpret mathematical formula. In businesses, it applies easily to software and computing. In the fields of sciences, it reliably and predictably converts raw data into intelligence and actionable insights, and in the field of research, it conducts preliminary data analysis and predict future trends. So in short, it is usable in all of the fields that we're going to work. So how does linear regression work? First, we're going to plot a line graph between 2 data variables, x and y. X, or our independent variable, is plotted along the horizontal axis, and y, or our dependent variable, is plotted on the vertical axis. Now we have our scatter plot. It is a visual way to describe the nature of the relationship between variables. If our slope goes upward, it means that it has a positive relationship or positive correlation. If it goes downwards, then it means negative correlation or no or negative relationship. And if it looks like this, it means that it has no correlation at all. Moving on to example 1. The height in inches of 8 high school girls and their scores on an IQ test is given below. Height as our independent variable x, we have 60, 55, 65, and so on. IQ scores, or our y variable, the dependent variable, we have 110, 103, and so on. So we are supposed to display the data in a scatter plot and describe the type of correlation and interpret the correlation in the data. So listing the data above, we're going to have 60, 55, 65, 66, 58, 68, 69, 59, which corresponds to 60 and 110, 55 and 103, 65 and 108, 66 and 116, 58 and 97, 68 and 115, 69 and 130, and 59 and 145. So we're going to plot the scatter chart. It looks like this. 55 corresponds to 103. So this is our first point. That's 103. And then the next point is 58, which has 97. So here we go, 58 and 97. And then the other one is 59 and 145. So we have here 59 and 145, 59 and 145, 60 and 110, and then 65 and 108, 66 and 116, wala ko siyang explanation, 68 and 115, and 69 and 130. If I'm going to erase this, the scatter plot looks like this. The slope goes upwards, which means that our problem has a positive relationship. Positive correlation, that as height increases, it means that IQ scores increases as well. Moving on to example number 2. A researcher examines the relationship between the number of hours a student spends studying, or our x variable, and their level of procrastination, or the y variable, measured on a scale from 1 to 10. So, our study time, we have 2 hours, 4, 6, 8, and 10 hours, and the procrastination, or the y variable, has 9, 8, 7, 6, and 5. So we're going to display the data in a scatter plot and again describe the type of correlation and interpret the correlation in the context of data. So here is what our scatter chart looks like. 2 corresponds to 9, 4 corresponds to 8, 6 corresponds to 7, 8 corresponds to 6, and 10 corresponds to 5. This looks like our slope is going downward, which means that it has a negative correlation, which means that as the number of hours spent studying increases, the level of procrastination tends to decrease. So to those students who are studying more, they have a lesser level of procrastination. The next topic, linear regression analysis. It is used to analyze the relationship between dependent and independent variables and determine how independent variables changes affect the dependent variable. So this is our formula that we're going to use. Y is equals to A plus B multiplied to X. Where Y is the dependent variable, X is the independent or the explanatory variable, A is the intercept, and B is the slope. So the question is, how are we going to find A and B in order to complete and find the answer that we're looking for? So here it is, the linear regression formula. For the slope of the line, we have B is equals to the number of variables multiplied to the summation of xy minus the summation of x multiplied to the summation of y over the numbers of variables multiplied by the summation of x squared minus the summation of x to the power of 2. Now for the y-intercept, there are two ways that we can get it. The first formula is A is equals to the summation of y multiplied by the summation of x squared minus the summation of x multiplied by the summation of xy over the number of variable multiplied by the summation of x squared minus the summation of x to the power of 2. Or we can also use the other formula where we have to connect, where we have to find first the slope of the line. This is A is equals to the summation of y over the number of variables minus the slope of the line multiplied by the summation of x over the number of variables. So let's have an example. A sales manager gathered data on the sales performance rating, which is our X variable, of different sales teams and their corresponding customer satisfaction, or our Y variable, scores over the past quarter. Using the regression line equation, we're going to predict the customer satisfaction score for a sales team with a performance rating of 78. So how are we going to get that? Remember the formula earlier. So here we're going to arrange the data on our table first. We're going to list our independent variables, which is the 34, 42, 71, 110, and 259. And then we're going to list our Y variables second, which is the 43, 51, 88, 130, and 314. And then here we're going to multiply both of this with each other. 34 multiplied by 43 is 1,462. 42 multiplied by 51 is 2,142. 71 multiplied by 88 is 6,248. 110 multiplied by 130 is 14,300. And 259 multiplied by 314 is equals to 49,926. Now how are we going to find the x squared? So here is our x variable, or the independent variable. We're just simply going to multiply it by itself. 34 to the power of 2 is equals to 1,156. 42 multiplied by itself is equals to 1,764. 71 to the second power is 5,041. 110 to the second power is 12,100. And 259 multiplied by itself is 67,081. Now, we're going to find each of their, if we're going to add them all, we're going to find their sum. So, the summation of x is equals to 516. The summation of y is equals to 626. The summation of xy is equals to 74,078. And the summation of x squared is equals to 87,142. Now, using the formula that was given earlier, we're going to substitute each of them with these figures. We're going to solve for the slope, which is here. The slope is equals to, this is the formula that I have stated earlier. So, the number of variables, we have 5, because we're going to go back. We have 1, 2, 3, 4, and 5. So that's what we're going to use as the n. And then the summation of xy is equals to 74,078. The summation of x is equals to 516. The summation of y is equals to 622. And the summation of x squared is equals to 87,142. And the summation of x is 516 to the power of 2. So RB, if we're going to input this in our scientific calculator, or we're going to solve this, is overall 0.279568495, or simply 0.28. That is our slope. And then we're going to solve for the y-intercept next. Now, I'm going to show you the two ways that we can look for the y-intercept. First is this one, where we are not going to use the slope. Second is this one, which is shorter, but we have to look for the slope first. So we're going to have this first method. So to solve for the y-intercept, we're just going to substitute the values that we have or we found earlier. So we have to put it here. Forgive me for the typo error, but this is what it will look like. So the sum of y is equals to 626. The summation of x squared is equals to 87,142 minus the summation of x, which is 516, and multiplied to the summation of xy, which is 74,078, over the number of variables, which is 5, multiplied to the summation of x squared, which is 87,142, minus the summation of x, which is 516 to the power of 2. Now, if we're going to solve it, and so I'm just gonna show you the answer, which is 96.3485316, or equals to 96.35. If we're going to use the other formula, which is a is equals to the summation of y over the number of variables minus the slope, multiplied to the summation of x over the number of variables, we're still going to get the same answer, which is 96.35. Which is 96.35. So for the next problems, I'm going to use this second formula in order to find the y-intercept, as it is shorter and it will be more understandable or less hassle. So now, determine the regression equation. We're going to use the regression equation now, which is the y is equals to a plus b multiplied to x. X is our constant, which is earlier the 78 that was stated in the problem that we had. So our y-intercept, or the a, is 96.34853116, plus our slope, which is 0.272795684965, or 0.28. If we're going to solve this multiplied by 78, we're going to get this value, which is 96.6280966, or simply 96.63. Therefore, we already have our answer. The customer satisfaction score for a sales team with a performance rating of 78 is 96.63. Moving on to the fourth example. A school principal collects data on a teacher performance ratings. This will be our x variable, or the independent variable, and their impact on student engagement levels, or our y, or dependent variable. Predict the student engagement level for a teacher with a performance rating of 88. This will be our constant in the formula y is equals to a plus b multiplied by x. So this is x, our 88. Now, our performance ratings, or x variables, contains with the figures 82, 88, 90, 85, 80, and 89, which corresponds to our y, or the dependent variable, the student engagement scores, which is 86, 90, 92, 88, and 85, and 81. So we're going to look for the student engagement level for a teacher with a performance rating of 88. Here again, as the first step, we arrange the data in the tables as shown earlier. So 82 multiplied by 86 is 7,052. 88 multiplied by 90 is 7,920. 90 multiplied by 92 is 8,280. 85 multiplied by 88 is 7,480. 80 multiplied by 85 is 6,800. 89 multiplied by 91 is 8,099. And then for the x squared, we're going to multiply or get the answer by multiplying 82 by itself, or 82 to the power of 2. 80 to the power of 2 is 7,396. 88 to the power of 2 is 8,100. 90 to the power of 2 is equals to 8,464. 85 to the power of 2 is 7,744. 80 to the power of 2 is 7,225. And 89 to the power of 2 is 8,281. Now the summation of x is equals to 514 if we add all of this here. And the summation of y is equals to 532. The summation of xy is equals to 45,631. And the summation of x squared is equals to 42,210. Now we're going to solve for the slope. As I have said earlier, I'm going to use the second formula, which is the a is equals to summation of y over n minus p multiplied by the summation of x over n. So first, we're going to look for the slope. We're going to use this formula. As I have said, we're going to substitute. The number of variables are 6. Here, as you can see, 1, 2, 3, 4, 5, 6. We have 6 variables. So that's what we're going to put. And then the summation of xy, which is 45,631, minus the summation of x, which is 514, multiplied by the summation of y, which is 532, over the number of variables, which is 6, multiplied by the summation of x squared, which is 47,210, minus the summation of x to the power of 2, which is 514. So if we're going to solve all of this, we're going to come up with the 0.01772975241, or simply 0.02. That is our slope. And then, now next we're going to solve for the y-intercept. Since we already found the answer for our slope, we can use this formula already. So again, substitution. A is equals to the summation of y, which is 532, over the number of variables, which is x, minus the slope, which is 0.01772975241, multiplied to the summation of x, which is 514, over the number of variables, which is 6. So we're going to arrive at the answer 87.14, or 14781788, or simply 87.15. Now we're going to use the formula for the linear regression analysis. Example number 4, this is our answer. Y is equals to a plus b multiplied to x. X, as I have said earlier, are constant, which is 88. So y is 87.14781788 plus 0.01772975241, which is our slope, and then multiplied to our x, which is our constant variable. We're going to arrive at 88.70803609, or 88.71. The result shows that the student engagement level for a teacher with a performance rating of 88 is approximately 88.71. So that is our y. Now for our last example, example number 5. A product manager analyzes the quality ratings. This is our x, or our independent variable, given to different product lines and their corresponding customer satisfaction ratings, which is our y, or our dependent variable. Now we predict the customer satisfaction rating for a product with a quality rating of 95. So here are our figures. Our x variable, or the quality ratings, contains 85, 87, 88, 92, 86, and 93. And our customer satisfaction, or our y variable, which is 93, 89, 94, 96, 91, and 97. For the first step, again, we arrange the data in the table as shown. Our x variable we have here, and then we're going to count how many variables there are. 1, 2, 3, 4, 5, 6. The same as earlier. x multiplied to y, 85 multiplied to 93 is equals to 7,905. 87 multiplied to 89 is 7,743. 88 multiplied to 94 is 8,272. 92 multiplied to 96 is 8,832. 86 multiplied to 91 is 7,826. 93 multiplied to 97 is 9,021. Now the x squared, 85 multiplied by itself, or 85 to the power of 2 is equals to 7,225. 87 to the power of 2 is 7,569. 88 to the power of 2 is 7,744. 92 to the power of 2 is 8,464. 86 to the power of 2 is 7,396. 93 to the power of 2 is 8,649. Now, if we're going to add up all of these values with each other, we're going to arrive at these answers. The summation of x is equals to 531. The summation of y is equals to 560. The summation of xy is equals to 49,599. And the summation of x squared is equals to 47,047. We're going to use the formula given again, and then we're going to substitute the figures with the formula given. Now we're going to solve for the slope. B is equals to the number of figures, which is 6, or the number of variables, which is 6, multiplied to the summation of xy, which is 49,599, minus the summation of x, which is 531, multiplied to the summation of y, which is 560, over or divided to 6, or the number of variables, multiplied to the summation of x squared, which is 47,047, minus the summation of x to the power of 2, which is 531 to the power of 2. If we're going to solve all of this, we're going to come up with the answer 0.7289719,626, or simply 0.73. That is our slope. Now, we are going to solve for the y-intercept, which is the summation of y over n, which is 560 over n, minus the slope multiplied to the summation of x over the variables, which is 0.7289719,626, this, multiplied to 531 over 6. If we're going to solve all of this, we're going to arrive at the answer 28.81931,464, or simply 28.82. Now that we already got our slope and the y-intercept, we can solve the linear regression, or we can predict the value that was asked earlier. Y is equals to a plus bx. This is the formula, regression analysis formula. So a, or the y-intercept, is equals to 28.81931,464, or 28.82 plus 0.7289719,626, or the slope, multiplied to our constant, which is 95, as stated earlier, given in the problem. So if we're going to solve all of this, we're going to arrive at 98.071,65109, or simply 98.10. Therefore, we're going to have a conclusion. The customer satisfaction rating for a product with a quality rating of 95 is 98.10. So that is how you solve for the linear regression and the linear regression analysis. I hope you learned something from me today, and that will be all. Thank you.